Hi, and welcome to day 3 or Wednesday of our professional development. Today, we're talking about units 5 and 6, writing classes in arrays and the APC essay content. We're going to go through a couple of potential sticking points for students in their understanding before digging into some misconceptions around writing and understanding functions, in really specifically pieces of arguments / parameters and return values and how those can start to trip students up. Finally, we're going to talk about some evidence-based pedagogy as always. And today it's themed about collaborative coding, so pair programming and peer review. I think they're in the opposite order actually in the slides below, but no worries. We're going to talk about both of them in relation to each other as well. So let's get started by looking at a couple of potential sticking points. So we're going to look at inside this writing classes content, 5.6 and 5.8 for just a second. And then we're going to jump into the array module or unit and look at traversing arrays. So we had this issue around parameters pretty quickly with students, where trying to understand the formal parameter specified in the method header as different or distinct from the actual parameter, the passed argument. And some of this is just because they might name their variables very different or very similar things, like in this example, in this thought that you can plug different numbers into that formal parameter and get different results, like reusing that function can get a little sticky inside their heads, that those are two different entities. Going on to scope of things as they're working through, what does the function have access to? Really making clear to them that there's these global variables that are accessible through the entire class and do not need to be added explicitly as parameters, versus the local, just in this function variables as shown in this second picture. And those are only accessible in this function. And it gets super messy when you have local variables in different functions that have the same name because they look somehow linked, and it's very muddy and confusing. So doing something like number versus num, anything to help differentiate that and really add some clarity is helpful. But that idea of scope is really hard, and that these variables are changing as you reuse these functions. So moving on to arrays, one of the biggest sticking points is what can be in an array. A lot of times we show examples with only numbers, and so it kind of breaks their understanding when you start putting things like strings into arrays. I would argue that showing your first few array examples with strings is often easier because they don't have to keep track of the number that's in value and the number that's the index. It's a lot more clear what the value versus the index is. I feel like almost every time I see someone introduce arrays, they're using an integer array, and it's just so hard in the student's head to juggle. Okay, in index 0 is value 1. And it kind of conflates that arrays start at 0 instead of 1, and what's the index and what's the value. And so really think it's really helpful to use something where you have an order like alphabetized, but you're doing strings. And just to see, again, the code visualizer we talked about yesterday in action works amazing for all of this content, specifically arrays. You can see it's going to instantly build my array. I can see them in order. I can see their little index up at the top left. I can see that it's actually referring to an array. This is not a primitive. An array is an object. And I can watch it print out based on, okay, I just printed 2, which was Carl or Carol. And that makes sense because index 2 is Carol. Off by 1 errors when iterating or traversing over arrays are really, really common. And so making sure they understand they start at 0. So when they're getting a return length of 10, the last index is 9 is one of those really, really common sticky points. And so having these visualizers really lay out what the indices are can help. And once again, not accidentally conflating the value with the index. Using something like strings where it doesn't look like an index can be super helpful. So looking more explicitly at misconceptions more around functions, returning a value is just like printing it. So this is kind of true in Python if you ever use the shell, but students think that this function call will automatically print true. They don't realize you have to wrap it inside that system.out.println to get it to print. So a lot of times they get really confused if they have this code and they're like, well, nothing's coming out. And you walk over and of course they haven't printed anything. So that makes sense to you, but not to them. Similarly, they think that return values are automatically stored. Something about it coming out of a function, it's just taken care of. It's printed, it's stored. There's something about the being returned that like there is some care taken with it. And that's just not the case. And so they think that magically this is being stored somewhere, but it's not assigned to a variable. It's not being stored anywhere. How would you ever call or access that again? And so sometimes the code visualizer, again, is a great way to show them, look, it's gone. Like there's no variable, there's nowhere it's being stored. Some think you must return a value into a variable. So this idea that you can directly put the function call inside something else, something that's not a variable assignment statement, that kind of breaks their brain a little. They think, no, you have to resolve this into a variable, and then in the if statement conditional, you can then call the variable. Putting those together, stacking or nesting those, really, they think it breaks under the hood for some reason. Similarly, just this idea of these function calls not evaluating in a reasonable way if you stack them or put them together. So in this case, they would think that print number is actually being passed this function call as opposed to what that function call evaluates or resolves to. So in this case, 14, and then the 14 being passed to print number. Again, a fabulous thing to look at the code visualizer with. This idea that arguments must be literal or variable, again, the stacking, the inserting of function calls into one another. It makes me think about code golf, the idea of making or solving a problem with as few lines as possible as a bell ringer. Here's 6 lines. Can you collapse it into one? Really have them practice nesting these function calls. They just, this idea that this is going to resolve to 14 and then the 14 is going to be passed into the print number. It's really, really hard for them. So let's actually try this in our code visualizer. Let's see what this looks like and how this could help. I think some of this is outside here. So we'll put this here, grab this, put it into my main method. Now it's a little messy, but we'll call it a day. And it's upset. Yeah, sometimes when you copy paste into here, it struggles a little bit. Just one of the nice reasons, the nice things about This can be around forever. That's fine. Cool, thanks. All right. So the first thing I'm going to do, I just executed this line. I'm going to do this double the num 7. Notice it hasn't even talked about this print number yet. And it's going to resolve that to 14 and pass it back down here. And you'll see that 14 gets plugged into print number. So you can really nicely trace the program flow for all of this. And then I can see that my number is 14. So code visualizer can be pretty helpful for really walking them through these execution steps. Oh, this idea that parameters and their values are linked. Again, if you have mutable objects and you're passing by reference, that could be true, which is why this is an extra tricky misconception. But all of these primitives in the immutable objects, they're being passed by value. And so updating num in here is not going to affect the num down here. Num is still 5 down here. And again, this kind of layers on scope, like this num only exists inside this function. This num only exists outside of that function. This would be inside your main. It would be really interesting as a bell ringer or an exit ticket or some kind of assessment to have students color in the lines of code where or indicate where that variable exists. What is the scope of that variable? Also, this idea that return values must be local variables. We're often returning things like num. And we do that all the time. Almost always you're returning something that has something to do with the parameter you passed in, the argument. But you can return actual literals like true, false. If you think back to the example of translating numeric grades into letter grades, you can return an A, a B as a string. And so those are some of the sticky misconceptions that specifically around functions and variable scope, etc. And now turning to pedagogy, evidence-based pedagogy, specifically collaborative coding. And so there's a lot of different ways you can have students collaborate around code. Last time we talked about peer instruction, where students have discussions around quick formative assessments during lecture. That's a really great way to kind of dip your toe into getting students to really work together. But there's a really wide range, and we're going to talk about 2 today. And one is peer review. They're still doing individual assignments, but they're going to kind of check each other's work, kind of like when you swap homeworks and someone sitting next to them checks. On the opposite end of individual assignments, all the way over here is pair, or if you have more than 2 students, mob programming. And that's very, very tied together, 100% working side by side. And normally this would have happened on one physical computer with 2 students sitting at one computer. Now there's tools for remote paired programming where you can be in different places while you do this. Generally what happens is people think they're pair programming and they're doing this divide and conquer programming where students kind of split projects down the middle, give each other a task, and they're coordinating. So it's not quite individual assignments, but it's definitely not the level of collaborative of true paired programming. So peer review. So a bulk of the coding is done by a single person, and then students swap work and offer feedback. Traditionally, it's done upon completion. This is kind of a struggle because you don't necessarily have any time to do anything with that feedback. Similarly, you can do divide and conquer, and then they come back and kind of combine and review the entire thing together. It's optimistic that they would review it together. But you could also do peer review on more regular cadence. So they actually have time, not just when it's done or right when they're trying to put two pieces together, get feedback from a peer. So that's what buddy programming is. So let's say you have a week-long project, they're going to work on it for 5 days. Maybe take the last 10 minutes at the end of each work block, or 5 minutes, to kind of look at each other's code, give feedback. And that way they have a chance to actually use that feedback in the next block, or they could start the block that way and immediately start working on that feedback. Oftentimes students get feedback and then are told to move on. So it's a really great opportunity for them to actually implement or act on that feedback. The other end of the spectrum was that paired programming. We actually have a webinar on paired programming, really digging into it. But it's this idea that you have two students, a driver and a navigator, sitting at one computer working on one piece of code, and they switch roles often. They should not have one student spending like a whole 45-minute class period in one role. Oftentimes, like when you finish a function, you switch. Some people do really strict role switching where they set a timer for 5 minutes and tell everyone to switch. It's kind of stylistically up to you. Often, if you can break an assignment into little parts, every time they finish one of those little parts, they would switch. It can be a little disruptive mid-process to switch. And so having it more based on where they are in the flow of work sometimes goes a little bit smoother. I would note that drivers control the mouse and keyboard. They're doing the physical typing. The navigator is not sitting there, and it's the harder job. Having to pay attention when you are not the one typing is really difficult, but they should be doing things like finding help resources online, giving directions, making suggestions, catching bugs, keeping in mind the big picture of the assignment. And switching roles regularly, super important, as well as taking breaks. It's really hard to stay focused for a super long period of time. And so after maybe 20 minutes of this, they might need a 5-minute break just to walk around and let their brains cool down. Yeah, if a partner is absent, making sure that they update that partner and just don't dive back into it where the navigator is completely lost on what the driver is doing. Why would we bother with this? It leads to success in beginner courses. It really helps those novice programmers. We see greater student satisfaction, enjoyment, retention. And some people are concerned that one of the students in the pair is going to skate by, not do anything. They're just going to listen to whatever the driver says or the navigator says and type it. And when they're the navigator, just kind of watch without offering anything. But we don't see this as much as people fear it. We see that research shows similar performance for paired programming compared to those with individual programming assignments on final exams. There are a couple of pitfalls that you as a teacher need to avoid. So one thing is assuming it's intuitive. You'll throw two kids together at a computer, say one's the driver, one's the navigator, go. It is not an intuitive practice. It's really hard. You should model best practices, have clear expectations. After they try it for a period, offer reflection. Think about, okay, if you're having this problem, this is how you troubleshoot it. You're also going to want to pair students with similar levels. If they're really, really different in terms of work speed or understanding, you're going to kind of lose that opportunity to truly collaborate and learn and take turns being the one teaching the other person. Some people worry there's a lack of transparency. So you kind of have to keep tabs on which student is doing what. Codio, you can actually see in code playback who typed what. So you don't have to worry about that quite as much. There's lots of software tools that can handle that if you set them up. A number of teachers will drop paired programming after the first attempt. They try it, it doesn't work exactly as they imagined. They're just like, no, we failed. pair programming is hard. You're going to have to be really patient. It's much more about soft skills than programming ability. A lot of professional programmers find pair programming very difficult. It's a hard thing to collaborate effectively, but it's an invaluable life skill. We also think that this equal driver time or number of keystrokes or lines of code, something concrete, means equal contribution. Students work at their own pace. Not every line of code is the same intellectually. It's really hard to quantify equal or equitable participation. And I would honestly not try to make that the goal. Maybe something just both have meaningfully contributed to the project, whether one is more time and the other is more lines of code. It's not really important in the grand scheme of things. So how do you actually set this up in Codio? So for pair programming, this is really easy. We actually know that social pedagogy, such as peer review, pair programming, even peer instruction, is particularly useful for novice programmers from systematically oppressed communities. So anyone who is not that kind of typical white male, economically privileged, they're going to be particularly served by this. But even the white male privileged students in your classes are going to get a boost from it. You actually can just toggle on paired programming in Codio and away they go. Codio is unique. There's a lot of tools that let you throw multiple students in, like a Google Doc. Replit, I think Coding Rooms has this functionality, but Codio forces you into that driver and navigator roles. Paired programming is one student typing at a time. And that anarchy mode that these other products do is not what the research with all the benefits is about. And so we don't know, and actually poor implementations of paired programming are not finding those same results in benefits. So again, anarchy mode in Google Doc is not the same thing as proper paired programming. Codio actually forces you into those driver navigator roles. And some of these other tools, just be really wary when trying to implement paired programming, because students won't necessarily keep those roles, and the tools are not set up to encourage them to only have one driver. So that wraps up Wednesday. There was a lot there around collaboration, arrays, functions. Tomorrow, we're going to do even more on arrays, array lists, and 2D arrays, which gets really interesting. So if you want to start working on that content, you can do that before or after the synchronous session tomorrow.